Okay, so what we are going to do today, as usual, we look at the schedule. So we talk a little bit about course. Okay, it's a very, interesting topic. I'm not sure about how much important, but for sure you need to address this issue when you are in the lab. And somebody of you already asked me about this issue, so today we're going to discuss it in depth. And then we continue our example, finishing using the use effect, and in particular the interaction with the server. We still have some functionalities we need to add, so in particular the delete and then add and edit. But the discussion is more general. It's not just about adding these functionalities. You can probably ask some AI and they will do it by, they will help you a lot. The point is understanding how web applications work, what's the best thing to do in terms of presenting information to the user, how to address the fact that, you need to wait for an answer from the server. Others can interact with the server as well. Web applications are distributed applications and so on. So we will have a discussion on this, and then we will try to implement all these ideas inside the example we carry on during the lectures. Okay? And before going on and talking about the topics, I want to remind you tomorrow there is another lab. We know the attendance at the lab is quite low. We're not really worried about the fact that maybe you already know things, and it's fine, for us. As long as you have all the basic concepts and all the concepts needed to pass the exam, for us it's fine. We don't really, want to count and, and check who is coming, who is not, because, time is yours and you need to use it in the best way. But just remember that labs are occasion in which you can, ask for information about anything, in particular about also the theory or something you didn't understand or some implementation you wanted to try in a different way and so on. And this is just, of course, for you that are in the classroom, but also for the people who are listening to us, hopefully very, a lot of people listening to us, in the recordings, okay? So, just remember that these labs are an opportunity and try to use them as much as possible, depending on what you think is appropriate for your case. Maybe you already know the topics, that's fine, but maybe you have some doubts about something. We are here, during the lab we are here to answer basically any question regarding the topics of the course, okay? I would say even future topics in case you need them, okay? Because, this is not the first year we give this course. Okay, so unless you have questions, I think we can just start and discuss about the topics for today. So I told you, I promised, I even promised that I would have to talk about this, the course, okay? So this cross-origin request sharing, it is basically an issue that comes because we have more than one server. And when you have more than one web server, you run into this problem, okay? Even in production applications. So it's not just an issue we have because we want to develop in this way with one server for the development, one server for the API, because this is the typical setup you also have in production environment, of course in big websites, okay? So actually, let's go a little bit back in time, and if you think what happened when you required a web page, especially in the past, you go to a server, the browser goes to a server on a URL that is specified by the user, or maybe because you clicked on the results of a search engine, and you ask for a page that contains HTML. This HTML contains reference to external resources, a lot of external resources. Typically images in the beginning, CSS, we saw code, JavaScript, and so on, okay? And actually these URLs are not restricted in any way. They can point to other websites as well, other URLs, other hosts, other ports, and so on, okay? As long as the server answers, this is a valid URL and speaks HTTP, of course. And loading resources from different web servers without any limitation was a kind of normal behavior, but actually in the really old days of the internet, probably before you were born, okay? I was born, I mean, maybe just a few years before, okay? Now the internet actually has evolved in something very different, okay? Internet was designed to show web pages, static web pages, documents, just with some links, nice links, you click and you move to another page, okay? Nowadays it's a platform to develop applications, okay? So it's something that you program and you do complex things, like we are doing in this course actually, right? Actually, it's a platform able to run application that can access and manipulate data, even personal and private data, and that's what scares us a lot, okay? That's the problem, right? Because, I mean, public information, probably we don't care that much, but, I mean, about private, personal information, every time you access a personal website in which you have your personal information, email, bank account, shopping cart and stuff, I mean, you want to preserve this privacy and you want to make sure that only the authorized people and devices can access this information, okay? And also we have the issue that browsers can also keep more than one page open at the same time, okay? I mean, nowadays the typical way is you having tabs, right? So, oops, sorry. I mean, you see the tabs and we have different web servers, completely different web servers, different websites, call it as you like, open at the same time in the same browser, okay? And this can create quite a lot of headaches in terms of privacy and security. How do we ensure that private data is not shared across web pages coming from different servers? Of course, I mean, across tabs, the browser can try to mitigate the problem because the browser knows there are different tabs. It's like you have two different windows open, and the browser knows that what does in one window shouldn't go into another window, okay? I mean, at least in principle, okay? But in practice, actually, it's not really exactly like this, especially when we will have authentication. That's a topic for a next lecture. We'll start talking about authentication, and when you have authenticated section active for some websites, that starts to be a problem, okay? Because this authentication status is shared between the different tabs and the different windows of the same browser, because it's something that is stored locally in the browser, and it is accessible by any tab and any window of the browser, okay? And we need to be very, very careful. So that's the picture that should explain what is the security risk that we are addressing now, today, and how then we mitigate this issue. So we have a browser that's a blue box, in which we have two windows that are open. They can be tabs. I mean, we don't really care. I mean, just a way of visualizing things, okay? So window number one was accessing in the beginning a web server that sent an initial HTML page, okay? And you thought it was a legitimate website. I don't know why. I mean, maybe you wrote like bank.com, and actually you might type one letter, and an attacker actually set up a website on this host name, okay? Or maybe they sent you a link to access your bank account. I mean, we are talking about banks because it's so easy to think in terms of money, but I mean, it can be anything, okay? It can be the page for your email and so on, okay? And so you load this page that looks like a normal page, traditional page you are used to interact with. I mean, it looks like your bank account homepage, or it looks like your email homepage, or maybe the Polito web page, and so on, okay? But somebody, actually the malicious writer of this HTML on this web server, has inserted some HTML code that does request to another web server, okay? Let's assume in this case it's this api.bank.com, okay? Your bank is very sophisticated, so basically it develops websites as we learn in this course, right? It creates a website with APIs, okay? And there is a server that serves information through these APIs to a client that is written in JavaScript and so on, okay? So there is this api.bank.com that can answer requests about, what is designed from the official web server of your bank, okay? And let's assume that, these URLs are short just for convenience, right, to show on the slides, but can be long. We don't really care. We can adapt to any URL. And let's assume that at bank.com/balance, you can actually, I should have written api.bank.com, sorry, /balance, okay? You can access your balance of your bank account, okay? If the browser doesn't do anything, doesn't do any check, or doesn't restrict this kind of request, actually you loaded the page from an initial web server that you thought it was trusted, right? But actually it was not. You were tricked into loading this page from this first server, and this page makes a request to a second server, okay? The second server, that is the one, that doesn't want to provide information outside a set of official web servers, okay? And this one, of course, is not included. But what happens is the browser does nothing. Actually, this request is sent. Why? Because, the browser needs to send this request to be compatible with what every browser does and did since the beginning of the internet and the beginning of the web, I would say. The web, not the internet. And so it issues the request. And actually, it happens that while you're visiting this new page, you also have an authenticated session with your bank, okay? In particular with the server of the APIs, okay? Because, you just interacted with the bank, you finished, and you left the tab open, you didn't close it. Actually, it's not about the tab, it's about having this session not yet expired, okay? And when you make this request, the browser automatically sends what we call cookies that are the typical way in which we store session information, okay? And so actually, to this API bank.com server, the request looks legitimate, okay? So it has no reason to think it shouldn't answer this request, okay? And we cannot do anything about this. And indeed, course will do nothing about this, okay? And the response will be sent back, okay? The problem is here. Now, you got some information, and you loaded this information in the memory of the window that is handling code and so on, coming from this tricky web server, right? And so basically, this JavaScript can do anything with the information that you load from this second server, including taking this information and sending it back to the previous website, so to the initial web server. Okay, and that's a problem, right? So actually, it doesn't matter. the second window is here just to remind you that you have maybe interacted before with your API bank.com server, and you still have a section active. And so this server will answer all requests it receives. Of course, that belongs to the session. Okay? And so, without additional restriction, that's the point here in red, the private data could be accessed by the JavaScript running in the first window coming from the first server. Okay? And then, of course, once you have access to this information, you can do whatever you want in terms of the attacker. Okay? Why I chose this IMG and I didn't do a fetch request? Because a fetch, the API that is designed to load information from a web server is more recent, okay? So it was born when this problem was already identified, and so it's sort of protected against this kind of behavior. So you cannot issue requests towards servers that, well, you can issue requests towards any server, but they have restriction in terms of what you can get back, okay? And the point is here, like IMG. IMG was a tag that was already there since the beginning of the development of HTML and so on. And so basically, if you want backward compatibility with all websites that are available anywhere in the internet, you need to load the resource that is specified by the SRC attribute, okay? And without additional restriction, this is a problem, okay? And so the browser must load, okay? In any case, all SRCs, all URLs that encounter in the page, okay? That is basically for backward compatibility. And so what's the point? The point is making sure that the page cannot access the information that is sent back from the server unless the server, the API server agrees that it's a trusted page, okay? So to limit the previous security risks, so what we just saw, nowadays, but I would say since 10, 15 years, even more, browsers do not allow the DOM or the JavaScript to access data and cookies coming from servers which are not the initial one, okay? However, the point is here, to avoid breaking the old web, so the old web pages, requests for IMG, link, scripts, and so on are still sent, okay? They are sent in any case, even if the URL points to different servers. That's a big problem, right? And not to break the old web, the received content is also rendered and incorporated in the page if it's, recognized, let's say, as legitimate content. So if you have an IMG tag, you expect an image format, and if you can render it, that's fine, you render it, okay? If you can interpret the CSS as CSS rules, you apply the CSS rules. If you can interpret the code as JavaScript, you run the JavaScript code, okay? But the point is that the DOM and the JavaScript cannot access such loaded content, okay? So the JavaScript loaded from the first server, okay? To avoid, basically, data stealing. So somebody takes this information and sends to a place where you don't want to, okay? And this is because the response of such requests could include private data if sent to a server from which an for which an authenticated session is already active, as I told you before. You just visited your bank account page and you didn't click on logout, which invalidates the session, so you still have the session valid for some minutes, hours, depending on the bank. And actually, the browser always sends a request, and the good and bad news is that it also always sends the information needed to reconstruct to access the resource with the active session. So basically, it always sends the cookie if the cookie is still valid, okay? And this is done automatically. We cannot prevent this behavior, so this always happens. And so what can we do at the moment? Well, actually, in practice, we need to find a way by which we can still do this operation, and actually this operation is done by all browser, sending the request and getting back the answer, but allow the DOM and the JavaScript to use this information only in specific situations, okay? So actually, in one of the browsers that nowadays doesn't exist anymore, Netscape, that's sort of the ancestors of many browsers, and this version 2.02, because 2.0, they introduced JavaScript in 2.0, so they realized the problem afterwards, okay? 1995, we're talking about 31 years ago, the content and the data coming from origins different from the initial server can be loaded but not accessed. Okay? So basically, since 13 years ago, actually browsers don't allow JavaScript and DOM to access any resource loaded from a server that is different from the one from which you started. Okay? Because of the problem we saw before. Okay? You can take some time and look at this picture carefully. And the problem is mostly with the DOM and JavaScript. Okay? Actually, this is called the same origin policy. Okay, so the word origin comes in. So content and data coming from origins which are different are not allowed to access the information. And so what is the origin? Actually, the definition of the origin is this one. The origin consists of the combination of a URI scheme, so let's say the protocol, HTTP or HTTPS, plus the domain name, plus the port number. Okay? It's a TCP, so there is a port number that corresponds to the service. There is a default port number for HTTP and the default port number for HTTPS, or if you specify it explicitly, that's a port. Note that the path here, the part on the right, is not included. Okay, so the origin is just the colored part. So just to clarify, is it the same origin in case we start with this URL, okay? So http website.com with some path, website.com/something else, example, yes, okay? Because same scheme, same host name, and same port, which actually is implicit port, that's the default for HTTP, okay? By the way, HTTP is 80, maybe you already know, HTTPS is 443. Example, say to any URL, that's fine, same origin. HTTPS, example.com and so on, or site page and so on. No, this is a different scheme, and of course also different even if it's implicit port. Okay? Or if you change the URL, the host name, the URL of course, and .website, API.website, www.website and so on, that's not the same origin because it's a different domain. Okay? So if you start from www.website.com, if you just have website.com, that's a different host name. Okay? And of course, if you change the port, it's also a different origin. Okay? So these are the rules that defines if an origin is equivalent to another origin coming from another URL or not. Okay? So you need to compare the scheme, the domain, and the port number. If they match, let's say the browser is confident that it's the same origin, so it allows the DOM and the JavaScript to access that content. Otherwise, it doesn't allow it. Okay? That is what's called the same origin policy. And you can read something on the internet as well. There are some links to go into a bit more details. So in short, what does this same origin policy do? Actually, we have the browser. We start from an initial web server. Okay? From this web server, HTTPS example.com 80. I put 80, maybe it was 443 was better example, but I mean, we don't really care, okay? Everything is allowed, same origin policy, because anything that comes from this server is fine, okay? As long as it is example.com and not www.example.com, API example.com and so on, okay? Good. If we have different host names, protocols, ports, and so on, actually resources are rendered and included into the page if they can be parsed. That means the image can be interpreted as an image, CSS rule can be interpreted as a CSS rule, JavaScript can be parsed in terms of JavaScript code and so on. But what comes from the server cannot be accessed here, inside here, from the DOM and the JavaScript coming from the original web server. Okay? But at a certain point, we have a problem. Actually, we already have the problem in our simple example application, right? Because we have an initial web server, the one that bytes serves to us. So, you know, the static page where we get all the JavaScript code from React and so on. And then we have an API server, right, where we perform the operation on the data. So, it's true that we can send a request, that's fine, but if we cannot read the answer, that's not so useful, right? Like load all the list of answers, load all the list of all fields and so on. If we cannot read the answer from the JavaScript code, the React JavaScript code that is served from the initial web server, that is a problem, right? I mean, all this structure based on multiple web servers can break. Actually, it's broken. So, what can we do? Well, of course, we can say, well, let's avoid the situation completely. And in a certain sense, this is possible because if you make these servers behave like if it were the first one, so you insert a sort of proxy and you redirect the request and so on, the browser doesn't see there are other origins and so on. But this is complex. This creates some additional load on the first server and so on. So that's not a situation that is used nowadays. Okay? So in short, we use option number 2, find a mechanism to allow cross-origin data access in a controlled fashion. Okay? Not everybody can access this data, but some origins in terms of the website that from which you started loading the application can access it. And this has a lot of advantages, and that's why it's used and it's so much used today, because it allows to separate the load onto different servers. You can have the API server, you can have a second API server for other operations, you can have a third API server for operations or information that doesn't belong to your website. Let's say weather forecast, that's a classical example. Stock exchange values and so on, okay? I mean, that's a possibility, and that would be very useful, right? And so you can allow to use any other server, in particular API servers, even third-party ones, even more than one, but we need to find a mechanism to control this access, okay? And the mechanism is the one we are going to describe now. So it's called coarse cross-origin request sharing. That is a standardized mechanism to handle these cross-domain requests. And in short, it is a set of HTTP headers that allows the browser to understand what is actually allowed or not in terms of access the response from from servers which are not the one from which you started, so from different origins. Actually, it's up to the server that you contact, the new server, not the one from which you started, but the others, to define which origins are accepted for the requests. Okay? I think there is a picture, yes. So, basically, you start from an initial web server, you get all the information to display the content of your page, including JavaScript code and so on. At a certain point, you want to access a second server. For our case, it's the API server. And typically, it is an API server. And actually, when you send a request, the browser automatically inserts an additional HTTP header, which is called origin, with the origin of the initial web server. Okay, so the scheme, the host name, and the port, in this case, it's implicit. And the response from the receiving server must include, using another header that is called in this way, rather long, access control allow origin, which origins can access the data in the response. Okay? If the two match, the browser allows the DOM and JavaScript to access the response. Okay? The DOM and JavaScript coming from the initial web server. Otherwise, the content cannot be accessed, and from the point of view of the JavaScript that may be issued a fetch request and so on, you just see something like failed to load and so on. Okay? So actually, you got the answer, you got the information that's inside the browser's memory, but it cannot be accessed by the DOM and the JavaScript. Okay? And that's really convenient, right, for our case, because here on the API server, you can say, okay, every request from site.com is fine. Think in terms about the bank, api.com, every request, API bank.com, every request from bank.com is fine, okay? And so if the attacker, you remember the attacker in the beginning, if it has bank1 or bank.co, not .com and so on, whatever, maybe the user doesn't spot it, but the browser sends the origin and checks the response of the server, and the server will not include, of course, other domain rather than one that is trusted, or other origins rather than one that is trusted, and the browser will issue the request, will get the answers, but it will not pass the answers to the DOM and JavaScript coming from the initial web server. That was the malicious one, right? Okay, let's see the example. I know it's a bit theoretical, but we can see the headers already working, okay? Because we already had to solve the problem. I told you, I mean, please trust me. We need to insert this couple of lines on the server. I think we can directly run this week's example, which is basically the copy of the previous week, just, you know, small adjustments just to make things smoother when we test them in the room here. So server, and we run the server. I already ran the npm install nodemon index. Okay, that's the server, and we need the client, right? So another window, week 10, React client. Again, I already run the npm install, npm run dev. Okay. So that's our web server. Our application with our web server. Our web server is running where? Actually, it's written here. Port 5173, localhost, that's the host name. Let me show it to you, right? This is scheme HTTP, host name localhost, port 5173, okay? While the other server is listening on HTTP localhost 3001. So the port is different. That's another origin. Okay, so when we do request towards the second server, that is a cross-origin request. Let's see it in the browser. Network tab, we need to reload the website because the network tab is active only, I mean, shows information only when it's open. Captures information only when it's open. So in the beginning, we load from localhost 5173, okay? And then at a certain point, I mean, all this stuff is loaded from Vita to load our React and content and so on. But at a certain point, we get the answer, right? You remember the list of answers, etc. And this is the request, actually. Yes, HTTP localhost 3001. Okay, let's have a look at the request headers. request headers, so many headers. Look here, origin, HTTP localhost 5173. I mean, this is done automatically by the browser, like the cookies. Every time it makes a cross-origin request, it sends which origin has done the operation, okay? I mean, not so important, but good to know. Let's have a look at the answer. So, response headers. Access control allow origin. Star, that means any origin, okay? Of course, this is quite unsecure, but I mean, we had to make the API server work last week, right? So, in short, there's no control about which origin can can read the response of the requests that are done, that are sent to our localhost 3001, okay? So you saw the two headers, origin, client to server, and the response, access control allow origin from the server to the client, okay? Let's for a moment remove this header from the server. And this header is actually inserted here, okay? App use course with an empty object basically means access, allow access to anybody, okay? Let's save it. I've run the server with nodemon, so when I save it, the server reloads, so it rereads all the code, okay? And let's see what happens. So I reload the application, okay? There's the application, but it's empty. No data. Actually, the data came from the server, right? So actually, the response is there. What's the point? The point is response headers. There's no header that allows the browser to understand that it can pass the information to the JavaScript that has been loaded from the first web server, the one served the one that bytes run for us, so the one on the origin localhost 5173. Okay? So, what is missing here? This access control allow origin. Without this, I mean, the answer is there, right? Because you can see it in the browser, right? But the JavaScript cannot access such information, okay? You can see it in the console. Cross-origin request block. The same origin policy disallows reading the remote resource at localhost API question 1 answer. Course header allow access control allow origin missing. Okay? So this is just, let's say, a warning. Okay? Sort of warning, and then we need to decide what to do in our JavaScript code. Okay? But actually, I mean, the point is not really we want to show something to the user because, I mean, actually, this should not happen in our applications. Because if we are designing our API server, of course, we want to put the server that serves the original web application in the list of origins that are allowed to read the answer from the API server. Okay? I just removed it now just to show you that actually the response comes back, but the browser prevents the JavaScript from reading the answer. And it also tells us something in the console. Okay? Indeed, network error when attempting to fetch a resource. That's what we say. Okay? The browser content cannot be accessed. It appears as failed to load. Okay? Because the JavaScript is some code, it runs, it has a fetch, it has a promise, the promise needs to be resolved in some way, either with the resolve or reject, okay, it needs to be settled, resolve or reject, okay. You remember there is a network error, it rejects, it's fine, Okay? I think we handled the error somewhere in the code on the client. Okay? But I mean, there's nothing we should print because actually that's a condition it should not happen. The point is that the browser in this way is sort of safe to use for any user that is not so confident with this mechanism, right? It doesn't pay too much attention to which word is actually written here. But this applies to us as well. I mean, you mistype something, it might happen, right? I mean, it's not like we... and there is an attacker on this similar URL. This is one of the typical occasions in which this kind of attack can happen in case the course doesn't work correctly. Like, indeed, I mean, we actually allow any origin, so that's not really good, but just for starting to make things work, I'm going to save the file. Of course, I mean, it's good for us because at the moment we are just learning, okay? And in this way, I mean, we are practicing and we are not caring too much about the security aspect. But today we will fix it, okay? Okay, good. So, a few more things. No course exists outside the browser. So the course is a mechanism just to protect the user of the browser, okay? If you issue requests towards the API server, I mean, the API server will answer, provided that maybe you need to have an active session and so on. So you made a request in a correct way. Actually, the request we have at the moment is very simple. It's just get me the list of the answer. No need for authentication, nothing. So you send a request, the server will answer. But outside the browser, the course does not exist, okay? And also the origin header, which sometimes the server might want to use, might want to check, it doesn't exist outside the browser. So you need to add it explicitly in case the server wants to see it, okay? But this is not a security mechanism in terms of preventing access to private information. I mean, preventing access to private information can be done only on the server side. And with the way that we are going to see at the end of this week, with authentication. I mean, you need to have a session, you need to provide some credential, username, password, and so on. Of course, otherwise, anybody can make the request. If you answer, it means that it's public information. Like the weather forecast. Okay? For the weather forecast, we don't care who is asking the information. That's fine. So, of course, allow origin, anything, that's fine. If it's my private information, I don't like that anybody from a browser can send a request because then it might be, I mean, a user might be tricked in using an application that doesn't behave as I expect through a browser. But to protect the information, I need to ask for authentication, okay? So for an active session and so on. That's the topic, one of the last topics for this course. Okay, so the web server must rely on proper security mechanisms to authorize data access, cookies, tokens, and so on. We will see cookies in this course, okay? And so, just remember the course is a mechanism for running web applications in a browser when you have multiple web servers because of the issues that we discussed until now, okay? So because otherwise users of the browser might be tricked into using an application that behaves differently from what we would expect, okay? But it's not a security mechanism for protecting data because you saw that the data came back in any case, okay? Okay, but that was a simple request. It was a GET request, right? So, I mean, get the information, either you get the information or you don't get the information, depending on what the server decides to do. I mean, the API server decides to do. But actually, there is a problem. The access control allow origin values not known before the browser sends the actual request. And you saw it, and you saw it only in the answer, right? So, it was here, answer. So, add It's just in the response. So after I send a request, how do I know if I'm allowed to use the information sent back from the server if I'm sending private information, like maybe for a post request or other requests, other HTTP methods and so on? That's a problem, right? And that's a problem that who invented CORS already solved. And actually, there is a possibility. You can check if the request is safe to send by means of the HTTP option method. Okay? So option is another HTTP method like get, post, put, and so on. But luckily, you don't have to do anything. Everything is handled automatically by the browser. But actually, we want to know what's happening, because then we will see this additional requests made from the browser, and we need to know why they happen. And we need to consider that to access some information in this way, there are two requests starting from the browser and going to the server. So there is this pre-flight request. You get this access control allow origin header. The browser checks if the origin is actually in the list of the origin which are allowed. If yes, it sends the actual request, post, put, delete, and so on. Okay? Such cross-site requests are simply said pre-flighted, because I mean this HTTP option method in this case is called a pre-flight request. Okay? Here it's in the title. This is performed automatically by the browser for every request. Okay? Because this header in the response could change depending on the URL and so on. We don't actually know what the server will answer before we do the request. Okay? Okay, good. That's some explanation also on the official pages like Mozilla and so on. Okay, if you want to check this information in more details. So example, unfortunately at the moment we don't have an example where we can test it because we don't have any post, put, or delete method, but at the end of the lecture we will have the delete method, so we can check that actually the delete method has a pre-flight request that starts from the server, okay, because we have a cross-origin situation, because we have the API server plus byte, okay? Okay, good, so option and so on, and you get a response with just the headers, access control allow origin, and it says which origins are allowed. Okay, there could be asterisk as well. Okay, not so useful with the asterisk, but I mean, in general, it needs to match the origin. Okay, so the browser allows the DOM and the JavaScript to access the response. And it doesn't happen like before, it says network error and so on. Typically, to the pre-flight request, the server also lists the methods, the HTTP methods that are allowed. Okay, post, get, options, delete, and so on. Okay, when we will have authentication, there will be one more issue. We need to send the cookies, so this session information to the second server, the API server, and this will require to do some modification to our code, because for instance the fetch, it doesn't send automatically cookie information in cross-origin requests, but it can do it if we tell it explicitly. Okay? But I will remind you when we talk about authentication, also because without this nothing will work. Okay? Okay, script tags. I mean, this is just additional information not really needed for our project, because in our project, I mean, we don't explicitly handle the script tags because everything is handled by Vite. So Vite compiles the code, creates a bundle that is served from the first server, and so we don't have to write explicit script and so on. Everything is inserted automatically by Vite. But in case you want to use this mechanism outside React and so on, since we are talking about course, and this is, I think, the only course that deals with web application. I mean, talking in general about web application in the cybersecurity course of study, let's say some points that might be useful for the future. In case you have a script tag in your HTML code, you need to make sure, that you do the correct thing. Like, remember that scripts loaded through the script tag from other origins and that are allowed runs with the same privileges of the other scripts. So everything is put together in a single environment, JavaScript runtime and so on. So it can access any variable inside your JavaScript runtime, okay? Remember this in case you really, and the point is, do you really want to load JavaScript from a third-party web server? Not sure, but the point is, only load scripts you trust, okay? And actually, we did it. You remember when we loaded Bootstrap JavaScript, right? Bootstrap, we say that it's nice, it's a framework with CSS and so on, a lot of rules, but it needs a little bit of JavaScript. This is actually a cross-site request. It loads JavaScript, and actually it can access this JavaScript. Why? Because it is served by these content delivery networks with this header, access control allow origin, star. You can check it. You can go back, maybe during the break I'll try, and just to load one of the old examples, I think was week 4 or 5. We loaded with the script tag, Bootstrap and so on. You will see that it's served with this header. Without this header, it doesn't work. Okay? We load the code, but it cannot be executed by the browser because the browser doesn't trust this code because it's from another origin. Okay? And in any case, you're loading something outside the places, the servers that you control. Always make sure that you include this integrity check, the hash of what you are loading, so you are sure that you're executing the code that you checked before. Otherwise, anybody can change the code. And the problem is that this code runs with the same privileges of all the other scripts in your client. And if it wants to steal some information, it can do. Okay, so it needs to be trusted code. Okay, and also that's why we need to include these attributes, cross-origin anonymous. We included in the past when we saw this, because it says, okay, be careful, it's a cross-origin and check the integrity. Again, this is an issue because in the past, we were used to load code without doing this check. So, this is the modern way that makes sure that the browser does the check, does the integrity check, and everything works correctly. And especially, it doesn't work when it shouldn't work, because there is an issue with the integrity or with the origin. Okay? Okay, almost done. An additional note, you remember that we talked about the content security policy at a certain point. That was a mechanism that we mentioned when we talked about cross-site scripting. You remember cross-site scripting, where somebody could trick the browser into executing code that we didn't want and so on. So in short, we say the browser just execute code if it comes from, etc. Don't execute JavaScript inline code and so on. There are mechanisms inside this content security policy that can also help restricting where the scripts can be loaded from. Okay? This is something that can be set from the initial web server. Okay? We say it's an header, or it's something that you can put into the header section of the HTML if you don't control the headers of the HTTP server. It's not a solution to the integrity issues, but it prevents script or CSS or images to be loaded from not whitelisted or unexpected locations. Okay, so it's more about these cross-site scripting attacks, but in general, also it's good because it's a way to prevent even starting loading the information from a place that you don't actually want. Okay? Okay, good. Last comment I want to make. If you load some code with the script tag as a module, that means with type module, actually we didn't see examples because, I mean, it's difficult in the sense that you need to have a web server to run these examples. The point is that if you load these scripts with type module, if you load them from the file system, they all have a null origin, okay? And so basically, they will not work because, I mean, it's not like null match with null. And in short, you need to serve all the files from a server from the same origin to make them work, okay? It's convenient because, you know, this type model allows us to use a lot of nice syntax like import and so on. But unfortunately, to make this example work, we need a web server, okay? That's why, actually, when we tried in the beginning, we didn't use this script type module, okay? Because actually we were loading the code from the local file system, okay? So just an additional thing you need to remember. Okay, so very quickly, because we already know how to do things, just one additional point, how to configure correctly the course. On the server side, there is a package for Express. This course is compatible with Express. Oh, okay, it was import. I mean, that's the old syntax, sorry. But, I mean, you see it in the example. We fixed the slide. Maybe I loaded the wrong set of stuff. I don't know. Import course from course. Okay, requires the old syntax with the other module format and so on. App use course. That's good, but I mean, it allows anything. We don't want to allow anything. So if you do app use course, enables or origins for all requests to the server because you did it on app. Okay. If you want, you can do it for single routes, but I mean, I think it's not so useful. Because all APIs that we will develop, and in general, all APIs that we make available on an API server are subject to the course rule, okay? Because simply are a different origin from the server from which we start using them, okay? So this is just for completeness. I mean, the nice thing is that if you use the course at the app level, it automatically handles all pre-flight requests for all routes, okay? So again, pre-flight requests handled by the browser automatically on the client, and also by the server, the response to this pre-flight request is handled automatically by the package. That's good, and that's what is recommended here. And the point is that course can take an options object where actually we can indeed set this origin. Okay, that's a default configuration. That is the star that we saw before, right? And methods, all methods, and well, what to say in case there are issues and so on. Okay, you can click and see the documentation, but I think, I mean, it's important to see what we should do in our application. Okay. Origin, HTTP localhost 5173, okay? It will be required for the exam. Also because if you also need to handle credentials, these cookies and so on, you cannot use the star. That's forbidden. Because, I mean, it doesn't make sense. You send credentials, so this cookie and so on, to access private information, and then you want to make everything, I mean, the response available to everybody. That doesn't make that much sense, huh? Right? So it's forbidden. So we need to explicitly list the origins that are allowed, okay? And actually, let's try. And then I think, yeah, we can stop for a break. So actually course, origin, yeah, not star. I mean, my website, do you know which is my website? No. 5173, okay? Save. I saved it, okay? It will continue working, of course, right? Okay, good. But in this case, you will see response in the header. Access control allow origin 5173. Okay? Just be careful. If it is wrong, it doesn't work. Okay? 5174. Save. Okay? So it means that you need to configure everything correctly, of course. See, now it's 7.4 and it's running on 7.3. That's a different origin. I mean, this is a toy example, of course. But it means also that in a complex configuration with production servers, maybe more than one server, more than one origin, user can start from bank.com, www.bank.com, and so on. You have different origins, you have different API servers. Configuring cores can become a bit complex, okay? Because you need to think about all the valid possibilities that you want to allow, okay? And also, I mean, this will be mandatory when we will have authentication, I will remind you. And this also means that you will always need to start with the localhost 5173. But typically, that's not a problem. But in practice, it means you cannot run two instances of Vite on the same machine when you are developing, right? Because you need to have this course enabled for a certain origin. That means host, that is always localhost when we are developing here, plus the port, okay? And the port needs to be known by the server. Okay, so let's fix it, 5173. It will work. Okay, good. So I hope you got a course concept and why we need it. Okay, it's mostly to protect the user of the web server from, using an application that seems to be legitimate, but it's accessing information. It can access that information, but then it uses this information in a way that is not appropriate, okay? So it basically steal this information, send it to some other places, okay? Where we don't want to send it. Okay, and again, we need to use it because nowadays the modern web applications are structured on multiple web servers, okay? And so we cannot avoid using it. But today we learned why we need it and how it works, okay? So, this next topic is about, continuing the discussion with the APIs, how to load the information, and so on. we can have a break here, 10 minutes break, okay? And then we start again and we continue the discussion. Now we have the course in mind. We know that we are able to access this information, why, and we try to understand how to handle all the issues that can happen. Multiple servers, clients that receive an answer which is slow. Takes time to retrieve an answer, what the user should do, and so on. Okay? If you have any questions or comments, feel free to ask. Otherwise, we can break for 10 minutes and start again at 2:30, more or less. Okay, thank you.